polynomials. We've looked at the linear function earlier in the year. Then we looked in more detail at quadratic functions, so the powers going up. That's pretty much it as far as 2-unit goes. Then with extension, we take it a step further and say, well, what about any polynomials in general? So this topic's looking just at any polynomials. Doesn't have to be linear, doesn't have to be quadratic, could be anything. So some definitions to start off with. A polynomial is basically an algebraic expression. It's an algebraic expression, and where we have all different powers of x. A couple of key things though. Well, this is a little bit trivial. Pn does not equal 0. Because if the last term was equal to 0, then it wouldn't be the last term. The n minus 1 would be the last term. So it's really trivial, that one. But the next bit's important. N has to be positive integer, or of course it could equal 0, because a constant number technically is a coefficient of x to the power of 0, which of course is 1. So as I said, the P0, the P1, the P2 up to the Pn, coefficients, we've seen that word before. The index or exponent is another word for an index, hence the term exponential when we look at exponential graphs. Basically they're the powers. The degree of a polynomial, and this is why the Pn can't equal 0, because the degree is considered the highest index. So if Pn was equal to 0, n would no longer be the highest power because it wouldn't be there. So it's always a polynomial of degree n. Sometimes you see the word order used instead of degree. So of order n, of degree n means the same thing, whatever the highest power is. So a quadratic equation, therefore a quadratic would be a polynomial of degree 2. Its highest power is 2. The leading term, interesting expression, because the way we've written out our general polynomial is actually the last term, not the first term. But the leading term is the term that has the highest power. So Pn x to the n, as opposed to the leading coefficient, which is just Pn. So make sure you read the question carefully. If it just asks for the leading coefficient, then you don't put the x to the n in. It's just interested in the coefficient. But if they ask for the leading term, then you put the x to the n in as well. And a monic polynomial is when the leading coefficient is equal to 1. When a polynomial equals a number, usually 0, then we call that a polynomial equation. When it's equal to another pronumeral, generally we tend to say y equals, but that becomes a polynomial function. And when it's just, I didn't put this bit up there, but when it's just polynomial x by itself, then it's simply a polynomial. The roots, we talked a bit about this in quadratics, it's still the same idea. The roots are the solutions to the polynomial equation, as opposed to the zeros, and they're technically the values of that make the polynomial 0. So the answers are exactly the same for the roots of 0, but we tend to talk about roots of an equation and zeros of a polynomial. But again, you'll see people interchange those words, so it's not that big a deal which one they tend to use. Alright, I've got 4 different expressions here, no cheating, and looking at the sheet. We want to know which ones are polynomials, and if they're not, why not? So what about the first one? Is that a polynomial? Oh, I heard a no. Why not? Because of which bit? Right. We said all the powers had to be whole numbers. Half's not a whole number. So, no. Can't have a fraction as power. What about the second one? Why not in this case?
Can't be negative.
Well, it's not negative. It's positive 4 on x squared plus 3.
It's still negative.
What's negative?
It's negative.
Okay, so a bit more information. The power can't be negative. I mean, technically, if we factorise that, we'd get 4 outside of x squared plus 3 to the negative 1. Whilst we can't actually expand that out, it still involves a negative power. Well, what about if I turn it upside down? X squared plus 3 on 4.
Yeah.
Yeah. Oh, there you go. I actually put that in there. Yeah, that one's fine. The coefficients are allowed to be fractions. Right, so that one's really a quarter x squared plus 3/4. What about the number of 7 by itself? Let's check. Yeah, that's fine. Because remember we said constant numbers are really the coefficient of x to the power of 0. And x to the power of 0 was okay for polynomials. So yes, that would be a polynomial of degree 0. Have a look at that. Determine whether it will end up being monic and what's its degree. So, who thinks it's monic? What's its degree? 1. 3. You've changed your mind, have you? So you think the degree is 3? Oh, the coefficient's 1, you're saying. Okay. But why don't we get x to the power of 4 there? I mean, we've got 2x squared times 4x squared there. Well, let's see. If we expand the whole thing out, and you're right, because those x to the power of 4s end up cancelling. So we do end up with x cubed, so it's monic and it's of degree 3. Alright, so that's the first part of polynomials.